I'm Gabriel Oreta.
I'm Maria Ruano Najarro, and this is
Sounds like Infrastructure.
I've always been struck by the incredible height of skyscrapers. Did you know how tall the tallest building in the world is? The current record is 2,717 feet. That's over half a mile. But I'm sure, somewhere in the world, an even taller one is already being planned. Have you ever wondered how tall they are downwards? What I mean is, how many feet would they have to build underground to support such a height above? And how do we build the tallest buildings in the world?
Humans always seek to outdo themselves in all areas of life. We want to make the fastest internet networks, the most sustainable cars, and the tallest buildings.
The first building that can be considered a skyscraper was the Home Insurance Building. It was built in Chicago between 1884 and 1885, and it was designed by the American William Lee Barrow Genie. It was 10 floors high, a true giant for its time.
But why do people build skyscrapers? Is it just for the aesthetics? Beyond providing good viewpoints and attracting tourists to their cities, do they have an impact on our world?
La razón de su construcción suele ser el máximo aprovechamiento.
Skyscrapers are built to maximize the economic use of land. That's why you usually find multiple skyscrapers clustered in commercial or residential areas where land values are eye-wateringly high.
Donde el valor del suelo es elevado.
One of the reasons for the growth of this type of building is real estate issues, due to the limitations of available land in premium locations. Another is sustainability, because higher urban density makes for a better use of a city's services and amenities.
Y que aprovechan el colectivo que reside en ellos.
Eduardo Ortega is the head of the architecture department of Ferrovial Construction. He supports both project and construction execution in the company.
After that first skyscraper, they kept growing and growing, and even becoming iconic pop culture images. Do you remember that black and white picture of the workers having lunch on a steel beam? The photograph was first published on the 2nd of October 1932 in the New York Herald Tribune. They were sitting 650 feet above the ground on the 69th floor of Rockefeller Center in New York without any apparent safety measures. They didn't even wear helmets. Can you imagine something like that now?
Safety is the most important thing. When building a skyscraper, even the tallest buildings, we call them the super tall buildings now. It's not just a skyscraper, they're super talls. Safety is the first thought in design, in how we design the materials for installation, the rigging connections, the whole plan. Safety has to start at the very beginning because it's a dangerous work. Working on a tall building, if not controlled properly, not only for the physical safety of the workforce, but of the community surrounding the skyscraper. So imagine you drop a hard hat, even comes off your head at the 70th floor. It's not going to land where you expect. It's going to land in the worst spot. So you want the most basic safety thing, even keeping your hard hat on your head in a strong wind is extremely important. Since starting in construction safety, I started in construction safety in the early 2000s. And even in my own career, I've seen a big improvement in health and safety within construction. The construction industry has evolved a lot over these last 20 years in health and safety. Has safety always been the first and foremost on a construction project, on a skyscraper project? If we go back far enough, probably not. In the early days, safety was, I think if you could keep all your fingers and toes and you were successful on the job. But we've evolved a lot since then.
Benjamín Juárez is Ferrovial's Director of Health, Safety, and Wellbeing. In those early years, skyscraper construction was still a nuance, uncharted territory. Buildings with 20 to 30 stories were considered skyscrapers, which would seem crazy today. The first one built in Europe was in Rotterdam. It had 10 floors and was just 141 feet tall. In Spain, the first of the modern era was the Telefónica building in Madrid, which took almost 3 years to build, and stood at 290 feet tall, 15 floors.
Taking into account the size of skyscrapers and how they have increased over the years, what is it like to work so high up? If the building is 1,000 feet tall, would we need 1,000-foot cranes? Imagine having to lift all the building materials up there.
Health and safety starts with proper planning. So when you're designing a building, you're designing the means and methods of construction, you're determining the equipment that's going to be used. All of this, health and safety, starts in the planning, long before mobilization in the design phase. Then you continue that plan as you're mobilizing onto site and you're planning every day. What are we going to accomplish today? What's on the plan for today? And you plan to do the work safely for that day. You can go one step further. What we do often now is doing this last-minute risk assessment, that point of work risk assessment. So after lunch, after break, before you start a new task, to re-observe, is there anything dangerous here that I need to be aware of and need to correct before I continue on? So I would say, first and foremost, planning for a safe job is important.
There are tens of thousands of skyscrapers around the world. There's nearly 100 in Spain, and one of the most iconic is Torre de Madrid. Why are we bringing it up? Well, it was the tallest building in Europe for almost a decade, although it's been taken by many skyscrapers since. The most curious fact about it is its location within Madrid. The project was launched in the middle of Gran Via, one of the busiest streets in the country.
How significant was this at the time of its construction? How much does the terrain and size of the plot influence the construction? What should be taken into account in a project like that?
Para el diseño de un rascacielos, debemos considerar
For the design of a
principalmente
skyscraper,
dos factores.
we have to consider two factors. Firstly, aesthetics, being an iconic building, with a presence in the skyline of the city, changing and even defining it. And then, technical issues, the foundations and structure, especially in relation to the wind and earthquakes. We also have to take into account the conditions of the plot of land, the resistance of the ground, the deep foundations we have to design, the presence of water, and the groundwater table. It's possible to build even in difficult ground conditions, like in Mexico City, on clayey lake beds, or in areas prone to earthquakes like Japan, Chile, and the west coast of the US. But the size of the plot isn't a restriction. There are small lots with unbelievably tall buildings. The architect has to know how to understand the site, its relationship with the city, with the built context, to know what the image and structure of the building is going to be. He also has to know how to envision what the program doesn't say. We have to think it through because there are really important factors that aren't in the program. When we have this information, we build a conceptual base to then define the process of the project. We work with physical 3D models. When these buildings are at a monumental scale and have a big impact on its surroundings, it's important to study what they are going to be like in their spot. This is the first big challenge.
Jorge Iglesis is an architect and professor at the University of Chile, and he also runs an office in Santiago specializing in public architecture.
Skyscrapers are built almost everywhere in the world. In New York, Barcelona, London, Dubai. There are more and more of them, but they are definitely not all built in the same way. How a skyscraper is built is always influenced by its surroundings.
I have an architect's way of seeing the world. In the high-rise buildings that we have made in Santiago, I noticed that the news reports on them talk about the height of the building, how much reinforced concrete, glass, and iron were used, the speed of the elevators, the size of the water tanks, and the curtain walls. And these figures might impress the public since they are huge numbers. But they are not what truly matters. The building could be garbage. Sometimes I read its floor area is equal to a soccer field. What an enormous building! But the greatness of a building isn't defined by the amount of concrete, the tons of iron, or the speed of the elevators. It comes from the architect's vision and design, how it fits into the city and its uniqueness. Buildings like the Seagram's building in Chicago was designed to be extraordinary. What matters is how it reaches the ground, the finishing touches, how it connects with the nearby buildings. The Ford Foundation building in New York has an interior patio with its own microclimate, so that workers are happy and comfortable. For a truly great building, you need great ideas, not just to manage the construction and structural aspects.
No solo manejar los aspectos constructivos y estructurales.
Both the aesthetic and the technical aspects are important. From the influence of the area to the way the skyscraper can change, for example, the wind flow.
Al construir en un entorno urbano definido,
By building in a defined urban environment, we are altering the face of the city, the skyline. These changes also affect the local climate. Of course, building large blocks of concrete, glass, and steel can redirect the wind, especially the horizontal currents that collide with the building. The air is forced to rise or fall, to escape, and these currents affect pedestrians. Depending on how the buildings are positioned, wind phenomena or wind corridors can be created in the streets, like the Venturi effect, when a narrow street creates a kind of tube with higher wind speeds. There can be other consequences too, like heat islands. During summer, when the temperature goes above 100 degrees Fahrenheit, the heat gets trapped in the asphalt, and high-rise buildings stop it from cooling down at night. That's why areas with large concrete megastructures are so much hotter. In areas with lots of these skyscrapers, the ground gets really hot, and when this is combined with things like traffic or nearby industrial activity, it can end up producing thermal inversion. That's when the cooler air is below, near the ground, and the warmer air is above. It's an anomaly that creates a kind of lid that prevents the air from rising upwards and dispersing pollution. In Spain, we call this smog a beret because of how it hangs flatly over large cities, particularly in the morning.
con las famosas boinas que tenemos en las ciudades.
If the world's tallest skyscraper today is 2,717 feet high, at the beginning of the 20th century, the tallest skyscraper, well, it barely scraped the sky. The Singer Building in New York, which opened in 1908, measured 612 feet and had 47 floors. At the end of the 20th century, in 1998, the world's tallest skyscraper was opened in Malaysia and remained so until 2004 at 452 meters. That's the Petronas Tower in Kuala Lumpur.
We're always describing skyscrapers talking about feet up, towards the sky, but how far down does the skyscraper go?
Esto es como un árbol que uno no ve.
It's like a tree. You don't see the magnificence of its roots. The nature of the soil, what we call the soil mechanics study, usually determines the depth of the foundations. And then there are the water tanks, the power generators, and don't forget the cars. A 60-story office building requires a lot of underground parking space. Parking lots need to be well designed to manage the traffic with ramps up and down. It's a whole underground world. And its underground structure determines what's above, because everything above has to come from and be supported by what's underneath, especially in Chile, where the ground moves a lot.
Sobre todo en Chile, donde el suelo se mueve mucho.
The issue of security, with the evolution of technology and companies prioritizing it, has become essential throughout the entire construction process of the skyscraper. But surely, there is a moment when things get more tense. That point of no return, when everyone needs to keep their eyes wide open to avoid mistakes and safety breaches.
So as a building is getting taller, the safety provisions are becoming more evident, right? When you're 10 feet off the, when you're 5 meters off the ground, as opposed to when you're 400 meters off the ground, right? It makes a big difference. And so the safety requirements become even more evident. But I would say that the safety shouldn't change whether you're 2 floors or 70 floors, the precautions must be the same. One of the things that's very important in the building in a major city, skyscrapers are typically built in major cities, in urban areas where there's a high dense population. And so always considering the effect the construction, the building construction will have on the public. So as often we are building sidewalk bridges, they're called, or sidewalk protectors, so that you don't disturb the flow of the pedestrians, but you can still protect them by having a canopy that is protecting them from the possibility of something falling from the building. But you make sure that nothing falls from the building. So it's as a secondary measure to have these protections for the public.
Taste and design have also evolved over time. The details, the aesthetic of the buildings, everything related to clothings. Some ooze luxury and status, while others blend with the environment. But what they all have in common is that there's life within their walls.
Cuando uno hace un rascacielos o
When you
hace
make a
cualquier
skyscraper or any building, you have to think about how it's going to shape the urban fabric, how its design will relate to the context around it. The way it reaches the ground is very important. There are some buildings where it's just bam, they're there, towering above the street. But when it's done well, it connects with the ground. It's friendly to pedestrians. It's a pleasure to enter buildings like this that are bright and dynamic. They also need to know how to end, so they don't just look like they abruptly ran out of budget on the 103rd floor. It should be clear that the building was designed and crafted to finish there.
para que su diseño lo contara y lo explicara.
And beyond that, on the practical side, there is life inside the building when it's completed. The security measures for entrances and evacuations, how the elevators have to work in such a huge building.
Well, the building construction is, maybe the access is going to be different than when the building is complete. When the building is complete, you're going to have high-speed internal elevators that are moving people and their goods or stuff up and down the building. There's also provisions for emergency access for when when maybe those internal elevators aren't allowed or they're disabled for some reason. I mean, there's also redundancies in those so that you can continue to use them, but there's always going to be a manual way to get down by stairs. And so this is always considered in the building code of a skyscraper. These are the most basic requirements for living at those heights. So they're going to be different than when you are working on a construction site. When you're building vertically, you're not going to have interior elevators working, right? You're still building the building vertically. And so essentially you're building exterior hoist cars, if you could describe them like they're connected to the building by a mast, and you build them vertically. As the building is getting vertical, you build more track and you go more vertical up the building. And then when you demobilize this, you do it in reverse. You go down and demobilize going down. And so during construction, you're actually quite exposed. The first time I went to the top of a skyscraper, my first one was in Lower Manhattan. It was a residential tower, and it was the tallest residential tower at the time in North America. Now we've since grown taller. And the exterior hoist car has a floor, but it's essentially a cage. And as you're climbing vertically, the wind is blowing, you can see, and you're getting quite high, so that the street level looks very small, where pedestrians look like ants, right? And so it's quite tall. So you're very exposed. This is going to be quite different once the building is complete. You have, every modern convenience of a very nice lift inside the building.
In
In 1857, inventor Otis created the first elevator. This was crucial in enabling the vertical expansion of cities and the development of skyscrapers. Elevators defy gravity by reaching great heights, but the taller the buildings, the faster the elevators need to be. The fastest in the world are in the Shanghai Tower in China, which are around 20 meters per second, which translates to 74 kilometers per hour. That's about 13 times faster than a normal elevator in a residential building. But speed doesn't solve everything. You also have to manage the flow of people, especially at rush hours. So, software is used to predict when and where people will be moving. That way, the elevators can be positioned strategically to reduce waiting time, travel time, and energy consumption. When the button is pressed, the closest or most suitable elevator will respond.
El edificio que nosotros hicimos.
The building we made for Telefónica in Plaza Italia is right in the heart of Santiago, where you will find 3 of the city's most important parks. It was a huge challenge, but the challenge was more than just making a building that would stay up, that could survive earthquakes, and that could work efficiently. It was so much more than that. Firstly, it's recognizing where the building is. It fits with the plaza, connects with the buildings on Providencia Avenue and on Bustamante Avenue. In the original version of the building, the first floor was much more open than it is today. It used to be the tallest building in Chile. And after the 1993 bombing of the World Trade Center underground parking garage, Telefónica decided it didn't want so many people to pass underneath the building. A public project has to be a gift to the city. It has to contribute and improve its location, not just efficiently house Telefónica offices. It has to be a building that is loved and admired. That is considered as a contribution.
Thanks to Benjamín Juárez, Jorge Iglesis, and Eduardo Ortega for making this episode possible and continuing to add to the innovation in architecture, engineering, and construction.
Sounds Like Infrastructure is a collaboration between Ferrovial and Yes We Cast. Our team includes Francisco Izuzquiza, Alberto Espinosa, Sergio F. Núñez, Luciano Branca, Kevin García King, José García Guaita, Arantxa Gulías, Claudia Castañón Piqueras, Bethany Ashcroft, Fátima Gracia de Vargas, María Ruano Najarro, and me, Gabriel Ureta.
If you want to keep learning, I've got good news for you. There's many more great episodes of Sounds Like Infrastructure, and you can also check out our blog. I'm María Ruano Najarro, and this is Sounds Like Infrastructure.